Thanks, David. Thanks, John, and the other organizers for inviting me to the conference. This is my second time presenting this. First time was a year ago. The reason it's titled Part 5, it's because it's basically a continuation of a series of visualization presentations that I've been doing over the past 1.5 years. So my second one at Oceania, two at Stata UK, and one actually in Switzerland. And so this one, I want to focus on hierarchical data because I'll go into a bit of detail of what this is about. So I'll talk about 30 minutes to 35 minutes, and I'll leave the bit for more discussion and questions because there's always so many questions. So what has happened? Yes, ever since we were in this lockdown phase from 2 years ago, a bunch of us users who've been using Stata for a very long time. So I myself have been using it for about 12 years. So there's a lot of potential that we have, that's there within the Stata and the meta structures that one can exploit. And over the last 2-3 years, we've seen a lot of exciting developments in terms of data visualization packages. I myself did about 15 packages in the last 2 years that were mostly driven by engagements with the user community. Some of these are used a lot more than the others. I know because I get complaints all the time that there's a bug or something needs to be fixed or some feature needs to be added. And so with this set of visualization packages plus several others that the community has contributed, there's now a lot of possibility to do very interesting visualizations. There's a lot more in the pipeline, so hopefully you guys will see more stuff coming out over the year. And today I just want to focus a bit more on sort of talking about the rationale or the logic behind putting these packages together, and basically how to deal with hierarchical data. So what is hierarchical data? So even though the name sounds some fancy data structure you have, this is basically a overview of the structure that I want to talk about. Is that data usually comes in layers. So you have layers that are followed by subdivisions that are followed by sub-subdivisions. So there is a hierarchy between these. And in these hierarchies, you have both stocks and flows. And so given the nature of this data, you immediately can start thinking about all possible complex combinations that can come out of dealing with this structure. And so this kind of data people use all the time, and which are also called multi-layer data sets or multi-level data sets. And so what we want to do is basically we want to split the hierarchical data into different groups where we want to talk about visualizing stocks, visualizing flows, or stocks and flows together, or we want to talk about adding additional dimensions, for example, time. And so all of these together makes the data visualization fairly complex. So, we are in this realm of really this data visualization part. This is not so much related to the econometrics estimation parts. And so a lot of these visualizations are very powerful and useful if you're promoting your work or research or trying to explain the data. And so a lot of these existing packages exist that briefly I will also discuss these today. That makes these types of visualizations easier. And so the reason I had also taken time off from releasing new packages is I'm now in this process of fixing all of these. Even today, I fixed about 10 different bugs while working on the graphs for this presentation. So a lot of user community has started using these, and I get more and more feedback from this. And so we'll discuss some of the applications of what is out there and what can still be done with all of this information. And so, like I said, hierarchical data contains layers of information. So, for example, you can have hospitals, doctors, patients. You can have schools, teachers, students. You can have budget information where you have main categories subdivided. You can have populations at different administrative units. So what you're seeing is a snapshot of data set for Germany, where you have different layers. So you have the country on the very left side. Then you have the first subdivision, second subdivision, third subdivision, so which are called NUTS 0 to NUTS 3 regions. And then what you're seeing, the numbers that you're seeing are the populations in each of these. So, even here, you're starting to see sort of like all possible complex combinations that one can create, and how you can obviously collapse this to some reasonable unit of indicator that you want to use in your analysis. But essentially, this is the kind of data we want to look at. So I'm going to use this data set to explore or show you basically some sort of examples of how this can be used in types of data visualizations. So single layers are easy to map. Yeah, so so I've taken Spain as a case study, yeah, because Spain has 7 divisions at the below the national level. So it's has enough information, yet sufficiently simple enough to show the visualizations on a screen. And so if you're talking about just single layers, these are easy to visualize. You can use already the existing bar graph or the pie chart options or any other simple visualizations option that already exist in Stata. But the idea is that how do we represent all this whole complex set of information in a meaningful way that tells some sort of story that you want to tell. And so single layers are relatively easy to visualize. One can also do very creative stuff here. So for example, I have my own package, which are circular bar graphs, where one can show this in a polar dimension. And again, one can also add more layers to this. And so the idea is that in this sort of visualizations, you immediately see which regions are standing out, which are not. I mean, polar coordinates are not always the favorite ones, but this is just an illustration to show that you have inbuilt packages, you have purpose-built packages that can allow you to do this. And these are basically single line commands. So you just need to say circle bar population by nuts 1, and that will throw this graph out on the screen, and then you can customize it further. And so there have been a bunch of packages that I've worked on in the past year that were always, for me, interesting from a coding point of view. So I'll start off with one of my favorite ones, which is circle packing. So circle packing is, again, it's not the most optimal way of representing data, but what you have are circles packed within a circle. So the interesting part of this package is that this whole algorithm that was programmed that allows you to start with how to do all this mapping of data points within circles. It's available on SSC, so you can install it also directly. And so this is, again, looking back at the Spain data. What you're seeing here is circles showing nuts 1 regions, and then within the nuts 2 regions. I've labeled these, I've removed all the values to make it more readable. And so the algorithm makes this optimal fit of this information within a circle. And then you can go down another level. So what I've done is I've shown the third layer also in this data set. So what you're seeing here is, for example, ES30, which is Barcelona. So this whole region on its own contains just one city. You can see that in this region, this part is the main unit. Within this, I don't know the name, so I'm just using these references, except this one. And so you can see that circle packing allows you to show you some sort of information. The more data there is, the better the circle packing looks, the tighter it is. With few data, you can start seeing these holes and gaps. So it's a waste of space also, but makes for interesting visualizations because you can immediately show levels within levels, and people recognize that immediately, that these shapes mean relative weights in terms of what they represent. Then another community favorite has been tree maps. Tree maps are essentially like circle packing, but what we have are rectangles nested within rectangles. And so at the back of it, it uses what's called a squarified tiling algorithm, which you might have seen online in for example, the Observatory of Economic Complexity uses it, Our World in Data uses it, D3JS has a whole package on this. And so the whole backend, at the back end, the whole engine uses the Squarify optimization algorithm, which is one of the fastest algorithms out there. And so the idea is that the tiles are sorted from large to small and iteratively placed by either slicing or dicing a starting rectangle. So essentially you put a rectangle, you slice it, check for an aspect ratio, fit the next slide, and keep iterating till you have a layout. And so within this tree map dimensions, what you can see also immediately, this structure is immediately clear. This region has the largest share of population. It's the highest, it's the first one placed there. Then you have this region, then you have this region, and then you can start seeing the subdivision. So this is the first layer and the second layer plotted next to each other. Here I've added the third layer. So what you can do is essentially start taking data and start looking at different dimensions of this. And so again, for sort of categories which are fairly large and easy to differentiate, the tiling algorithm in this tree map can help you immediately visualize this information. And so within this package, you also have a lot of customization options. So I had presented this earlier, of preliminary version of this whole package, but this one is now fairly robust and can handle data fairly well and also extremely fast. So all you need to do is just say tree map population by level 1, level 2, level 3, and it will throw this graph out at you without you having to worry about all the algorithm part. Yeah, and so this is another way of representing this hierarchical information. Then moving on from this is the sunburst plot, where we have layers stacked on top of each other in a semicircle. So I'm still working on the full circle, but semicircle also fits nicely on the screen. And so this is the same data shown as a sunburst plot, where you have the first layers laid out in an arc. So the size of the arc represents the proportion of each region, and then that region is further subdivided into smaller regions. So essentially what you're seeing is they're also laid out in an order from highest to lowest. So for example, in this region ES5, you have this sub-region which has a majority of the population, and this we know is Barcelona. It's also, the whole region contains this whole sub-region. So this is just level 1, level 2. One can add another level, and then you can start seeing more and more variation. So the package itself allows a lot of customizations, for example, allowing users to have gradient fills, different ways of organizing and sorting the data, different ways of coloring this whole information, generating different graphs for different backgrounds. So again, the idea is to immediately show change of different layers over time. Within this package, you can also collapse categories of all the small categories that are not labeled. So essentially you can say, okay, only label regions that have a population of more than 500,000 or something like that. Yep. So yeah, so again, these kind of packages allows users to immediately show complex information in an easy to understand, in an understandable way. Yeah. Doesn't mean that all of these packages work for all different applications, but the idea here is that you can start playing with these, and some of them will look nicer than the others to tell a specific story, for example. And so another community favorite has been Sankey. There are already multiple Sankey packages out there, so this is my own version of it. And so Sankeys are interesting. I'll just show you two different applications of this. You can also install it directly from SSC. But essentially, Sankeys allows you to show division of data in terms of flows. So maybe this is not the best application for Sankeys, but what I've done here is I'm saying, okay, take the regions and subdivide them into smaller regions. So you can see the change in regions from a high unit to a lower unit. And again, this is from region level 1 to region level 2. You can go further, and essentially you start seeing variations in the sizes of these regions. You can also cluster them by different ways or reduce the information by different ways, but the possibility exists to use these kind of packages to sort of start showing more complex information. Sankey I'll come back to later because it's also an important package to show flows, but this is one application of how you can show also divisions of stocks over time. The gaps makes it look like the data is exploding, but if you set gaps to 0, it will just be horizontal lines that are split into different units. Again, I've restricted the labels to just show regions which are have more than 1 million population. Yeah. So this package, the tree cluster package, is sort of, within the hierarchy data visualizations. Tree cluster is the first primary package that came out, and then all of these others built on top of that. So this package that I released last was one of the first clustering algorithms that were put out there. So the idea behind this algorithm is that layers are shown in a tree structure. Trees can be horizontal or radial, and the package was released in December, so I'm still working on it, but it already allows a lot of customizations of layers and stuff like that. And so this is what it looks like. It's essentially saying that you have a starting branch, which is the whole country, has a population of 19.4 million. And then the line thicknesses represent how much of these subdivisions are. So everything is weighted relative to the highest value. So here what we're using is we are playing more with the widths of these lines to show relative differences. Within the smallest division, you can clearly see that some regions stand out more than the others. So the very thin lines have the smallest population, while these thick lines are clearly persist throughout the whole graph. And so this is a graph which is with all the different layers from nuts 0 to nuts 3. Again, I've restricted the labels to just areas with more than 1 million population. So here the tree clustering shows you immediately how many regions exist within, let's say, subdivision and subdivision. So it gives you a quick visual check of the bigger regions versus the smaller regions. For example, here you can clearly see that one region is dominating, while in this area you have a lot of small regions that make up this one whole region, because that's how these divisions are defined, are based on population dynamics. And so the interesting thing about this package is that once you've done this layout, which is in this sort of horizontal structure, you can also immediately or easily convert it into a radial structure. So this is a one-line command. You just say whatever tree cluster population by XYZ, and then just a radial, and we'll just convert the whole Cartesian coordinates into polar coordinates, which was a lot of fun to figure out. It might make it difficult for fewer observations if you're looking at this. So for example, here we're looking at the whole country, which is now branching out sort of into these smaller countries, and then the layout algorithm is sort of putting them in equal distances from each other. The more data you have, the better it looks. That's been my experience. For example, here I've removed the starting node, but I'm starting from the next node. And I'm saying, okay, plot the first layer, second layer, third layer, fourth layer. And then within this package, you can also play around with the radii or the distances. So you can squeeze some layers in, push some layers out. You can change the coloring. The colors still need to be added. So next versions will have more options to distribute the colors. But again, this sort of clustering also immediately shows you the overall structure of the data. So you have clearly more dominant branches in some regions as opposed to in other regions. So again, more skewed towards certain regions in this area, while here it's more equitably distributed. So again, one can play around with these visualizations to show all sorts of interesting dynamics or changes in data structures. And so moving on to flows. So flows are something, so basically are happening across layers. So even when you have bidirectional flows in terms of when you have network data, that alone makes it extremely complex. Yeah, so unless you're using some network visualization package that exists for Stata but needs to be upgraded. I just want to show you what can be done outside of the network visualizations given the packages that already exist. So I'm using this study that recently came out that estimated bidirectional flows. So the data is available online. And so they've done it for country to country pairs in terms of migration flows. I looked a lot for this information. It's not easy to find, surprisingly. So country to country migration flows for time periods, it's not so easy to collect. I think it's because definitions vary. So this study tries to homogenize all of that. The data is extremely rich. It's available for country to country pairs at 5-year intervals and by gender. So I've just collapsed it to the sub-region level. So for example, Africa is split into sub-Saharan Africa, and MENA region, Asia is also split into. So it's just to make sure the data is condensed to a reasonable level. So you can see some variation on the screen. And I've collapsed the gender category to all migration. And I've used the last data point, which was 2015 to 2020. And so basically what we have are then now region to region flows. So basically how much region X is sending to region Y. So here John mentioned Ben, so I'll just like to quickly highlight Ben's package that I've used a lot. What is basically his heat plot package. So heat plot package already allows you to do these grid matrix. If you have a square matrix, you can already do X to Y mapping. So I've taken out inter-regional flows, which are extremely high. So these also dilute sort of the other values. So just to give you an idea of how to read this. So Latin America and Caribbean is sending a lot of people to North America, for example. Or South Asia is sending a lot of people to West Asia, or East Europe and Central Asia are sending a lot of people to Central or Northern Europe. So again, as expected, these flows exist. So it's mostly global south to global north, but this sort of is one way of visualizing this information. The problem with this kind of visualization is that if you have these extreme points, they tend to highlight the underlying variations in these these other regions that we want to sort of explore a bit more. So we know that there is migration happening. It looks like it's extremely little, but that's the kind of variation we want to explore. So unless you're really playing with the scale coloring or scale grading, I just want to show you some sort of other packages that allows you to deal with this kind of information. So first one is this arc plot package. It looks like a mess right now. I just still need to fine tune it. But essentially what you're seeing are these thick arcs that are moving from one region to another. So if Latin American Caribbean is red in color, so red arcs are out migration, while incoming colors are in migration. So there you have all possible pairs shown as arcs. And like I said, as shown in the previous graph, you have these colors that are popping out. Here, these you can see also as these thick lines. So you can see this Latin America to North America migration, West Asia to South Asia migration, East Europe to Europe migration, and then you start seeing other variations also that were not so visible in the previous one, which is North Africa to Europe migration, or Southeast Asia is really sending a lot of people to other parts of the world with very little incoming links. So again, you can start seeing the distribution also of regions which are sending people out versus regions which are sending people in. And so let's say this type of visualization also allows you to start unpacking the flows in sort of a meaningful way. You can then decide, okay, maybe you want to reduce this information or collapse this further. But this is basically raw data visualized at the region to region level, and it's already giving you a lot of information. This is the classic Sankey, which is all the bidirectional flows mapped out. Again, easier to read, where you can start following the thick lines. So you can see that some of the bigger outsending, this is the larger the region on the left hand side, the more people it sends. So you can see South Asia is large, Latin American, Caribbean is large. And these are sort of the big receiving regions, which are North America and Europe, which is expected. But again, here you see all sorts of variations within the data. Again, this is a fairly easy package to use. All you say is Sankey value from variable to variable. Yeah, that's it. You can have multiple layers. You can have 10 layers if you have so much data. So you can really map the flows. And so this is a very good example of how you can look at stocks and flows. So both of these arc plots and Sankey gives you a very good idea of stocks and flows, and they immediately work. Yeah, people immediately see these and they start looking at how these colors are looking like. So I made these colors extra, bright for this presentation, but one can play around with colors and highlight some more than the other. And so this allows one to have a bit more variation. So like I said, these are two different ways of looking at this information. Some stuff that I'm still working on that I would like to show you is this chord diagrams. So chord diagrams are a project I started a long time ago. I actually presented this in my very first part 1. Yeah. I sort of abandoned this project because I wanted to focus on the other ones that I've already programmed or written about, but I'm coming back to this. So this is another visualization that allows you to do more network analysis. It looks horrible right now, but eventually the idea is that it will start looking more curvy, the typical chord diagram that you see. So I'm working on this edge bundling or arc algorithms that allows smooth generation of curves. So you will see more of this, or hopefully by summers it should be done. But again, a lot of this is in the works, and a lot of this makes it possible to do interesting visualizations in Stata. So again, all of it uses existing engine, Stata and meta engine capabilities. One does not need to rely on external programs to do this sort of visualizations. So if you see a visualization, you like it, does not exist, there's a very good chance you can program it. So if you don't know how to do it, you can always write to me and we can discuss it. And so just to briefly discuss what can be improved in Stata, because this is my slide I always talk about at the end of my presentation, is it'll be great if Stata gives us this ability to read images for all sorts of things, including image recognition or other satellite data processing. The rest are basically making life easier rather than looping over all sorts of combinations for colors, shapes, positions, rotations. It'd be easier if this makes it easy to read. So I don't know if I'll be awake for the grumble section. Maybe I wake up in the morning early, but it'll be good that some of these points are also addressed for the data visualization part, which I think should be relatively easier to implement. And that's it from my side. So thank you for listening. I don't know how much time I took or I have left, but the idea was to give you a quick overview of the different packages that can visualize hierarchical data. And yeah, all of this is out there. A lot more is in the pipeline. So happy to answer any questions or if you have any comments.
So Asjad, thank you for that. We're a bit ahead of time, but okay. we have got a couple of questions, and I've also got a couple of questions for you. One of the questions that has come in is about your tree cluster diagrams, and how do they handle missing data?
Yeah, so this one, you mean?
Yes.
So missing data currently is being dropped. But let's say if somebody says, oh, it would make a lot of sense if missing data is not dropped but marked as missing, that can be added. So if these kind of requests, I would say just email me or open up an issue for a feature request. And then usually in this cycle of development, they get implemented. So this is a relatively easy thing to introduce in these packages.
Okay, that's nice to hear. So if someone wanted to message you to get some tweaks or improvements, what's the best way to contact you?
So ideally, go to GitHub and open an issue for that specific package on GitHub, because I really get saturated with a lot of emails, and I myself convert them into new issues or problems or enhancement requests or bugs. But the best way to do is just open an issue on GitHub, because then if there's like 10 of them, then I just fix them all in one go. Okay. Otherwise, I'm getting DMs and emails and I don't know, all sorts of messages on all sorts of media.
So the best place to go is your GitHub site. And can you access that through your Medium website?
No, you just go on GitHub and show you GitHub. So if you go on the landing page,
we can't see you. You only see your Adobe.
I see. Let me just show you briefly. So if you go on my GitHub page, right, you have all these packages. So you can click on Sankey, for example, and then you can see there are 4 issues open. So I opened some other people opened it, and there you just click on new issue and say, this is the problem I'm facing. So this is the best way to get stuff done, because this is all the stuff that needs to be fixed for the next release.
Okay, cool. Now, another question for you is about the structuring of the data to prepare for these types of visualization. Is there what's the best way to structure that data? Do we need to structure it wide or long?
No, it's always long. You have variable 1, variable 2, variable 3 value. So that's typically how you get these kind of data sets also. So you usually don't have wide data sets for this kind of information. You will have category 1, category 2, category 3, category 4 value. So that's the structure. And then from there, it's extremely simple. It's command value by XYZ. So level 1, level 2, level 3. So it's fairly easy in terms of how you generate these graphs.
Okay. All right, I'm just checking through our chat to see if there are any other questions. We've got a couple of comments. We've got a comment here from Chuck Huber saying he's a huge fan of your visualizations, and he has asked an interesting question. How do you find time to do these? In between your lecturing and all the other work that you do, how do you find time to do these?
This is my relaxing time. So I find this relaxing and distracting from the other work.
Very good. And we've got a couple of people sharing your GitHub site address and your Medium site in the chat here. So that's really good. Thank you for everyone putting those questions in. So we are a little ahead of time, and I know it's a crazy hour for you to be presenting in the middle of the night. But thank you very much for being able to present to us again this year, Asjad. I really enjoy seeing your graphics. I know I follow you on Twitter. If you're not following Asjad on Twitter, then he's someone that you really should be looking to follow. so you can see some of the funky new graphs and visualizations that he makes available. If he's doing a new release, I know he's putting it out on Twitter and letting everyone know about it. You see the comments there, you see the number of likes that you get is just fantastic when you release those. So thank you very much for all your work that you do with those visualizations and helping to improve Stata and general acceptance and use of Stata across the globe.
Yeah, thanks everyone. And if you produce some interesting graph, please share it also. I'm always curious to see more from the community.